So this is work which is being completed at the University of Southampton as part of the work package on anatomy of disclosure risk with linked data. And this is work with David Martin and also Chris Gale in the Administrative Data Research Centre. So to give you an overview of what I'm going to be talking about today, I'm going to introduce zone design and explain the utility of this, and also how this relates to the new forms of data which we're starting to see, and what the value of our approach is. I'm going to talk you through the application of a zone design solution to a disclosive synthetic data set which we've just put together, and then I'll show some initial results from that. And then at the end, just talk a bit more broadly about the applications to other data sets and the bigger picture within which we think our approach has a value. So, what do we mean when we talk about zone design? Well, really, of course, aerial units are key for collecting and organising information. And the reporting of statistics, if we think about when we're looking at statistics, we're often looking at sort of specific locations. And depending on the actual units which are used, we can actually get different results. So geographers know this as the modifiable aerial unit problem. And then really, in terms of how that in terms of the results and this specific issue, there are kind of two elements to that. There's a sort of scale and an aggregation problem. Sort of practically, when we look at our units which we're using, often we're just thinking about polygons, so just shaded areas on a map. So we might think about electoral boundaries, or some of the census geographies which have been created, so output areas or local authorities. But when we're creating statistics, those will vary depending on the actual units which are used. And of course, we have the option to choose the number and the configuration of zones. So it's really important to think about those geographies and to think about what the outcome is in terms of the statistics which are being produced. And at the same time, we need to think about disclosure, so the protection of individual identities. And of course, with something like the census, there's that potential to identify individual records. And with individual locations comes that risk of identification of individuals. So we can think about different options to protect those identities, where standard approach is often just to aggregate over different geographical areas. So to take different zones or units to meet a sort of comfortable level in terms of population counts. And then there are some other options which exist and which are used, so things like record swapping or collapsing classes, so something like age to group and even to come up with different classes based on what's being looked at. And then also thinking about minimum thresholds, so what would our minimum population be that we would be comfortable with for a specific location. Now, zone design has been used in the past to create the output areas, the lower layer super output areas, and also the 2011 workplace zones. Of course, these are all census geographies which have been created. So now turning to think about the new forms of data which we see and how zone design relates to that. Well, obviously there's this growing desire, there's this sort of growing range and desire to make use of administrative data. But with that brings potentially more disclosure risks and privacy issues, especially when we start to think about what data might be being linked and the geographies which could be involved in that. And also, we have to consider that data linkage is necessary in terms of administrative records, because they can be very specific to one topic area. So it's necessary to link in other information, other data, which can give us more information on the individuals and the areas which can facilitate our research. And so we've seen a widespread investment in the access to make such data sets available with these new organizations. So we're seeing both a kind of pressure to make use of this data, and also such a great potential to realize the benefits of this data which is out there. But at the same time, we need to think about both the appropriate geographies for such analysis and also that confidentiality. So our study is looking at zone design in the context of linked data. And it's looking at what is the utility of an automated zone design approach for use with new forms of linked and administrative data. So our aims are to create a set of zones where we're providing sufficient information on the building blocks, on the geographies for research to proceed, yet we're providing the protection of the individual identities. We also think that there's the potential for the approach to give a quantifiable solution to the researcher, where there's a clarity over how the zones were created and what the implications of that is for the research and the findings which are made. So in this specific example, which I'll talk you through today, we're using MSOA coded individual level synthetic data. So this is a data set which has been created using a 2011 census geography and 2011 census data, where we're creating a set of synthetic, so artificial households at an existing census geography of the MSOA, and also using the postcode locations. And then alongside that, we're also using the index of multiple deprivation from 2015, and we're also using some information from the Health and Social Care Information Centre on a location of GPs within Southampton. So for this specific example, I'm going to be talking you through some results for Southampton. So this table, just to give you an overview of the sort of units that we're working with. So we've got just under 100,000 households in our data set which we're working with. We have about 45 general practitioner locations within the city. And then to give you an idea of the existing census geographies and the number of those and how they vary, we've got our MSOAs, the sort of coarsest one here with 32 units, and then we've got our LSOAs with 148, and our output areas with 766. So here we are. Here's a map of Southampton. So what we've got here is we've got our Thiessen postcodes. So for each postcode, we've got a polygon on the map here. And so those of you familiar with Southampton, we've got the sort of docks down at the bottom where we've got some of these bigger polygons which are just running out to the edges. And we've got the common up in the middle there, right up in the middle of the map. And so just mapped on here, we've got our GP locations, these pink dots. And And then you'll see how the geographies vary when we apply different zone design targets based on the population counts per postcode. So our first zone design solution is where we're looking for a target population of 100. And you may have noticed a very subtle difference from the previous map, but I'll just move back and forth a few times. And you'll notice that what our zone design solution is doing is it's collapsing some of these individual postcodes to create new building blocks which meet this population target. So for example, you'll see down here that we're combining some of these postcode locations to meet the minimum level. And then what it's possible to do is to go on to create a range of different zones and to apply a different set of targets. And what we see is a rezonation of the map with the amalgamation of other postcode locations and change as we come up with these different iterations. So the largest zonation which I'm presenting today is this one where we're aiming for a target of 200, and you'll see that when we change between the two maps, we've got many of the zones being merged in order to meet that target. And then our last map, which I wanted to show you, is the household distribution within Southampton. So we've used our postcode locations and we've created what we call offsets, where we're repositioning households away from the postcode centroid based on the count of the number of households per postcode. And so we see just this spread of households across the locations where, according to 2011 census data, we had individuals living. So we see, again, that there are no households around by the docks here, and also this large rectangular area in the middle, which is where Southampton Common is. And so what we're doing with this data is we're calculating using a GIS software the distance to a GP. And so we can work out which is the closest GP from each of our individual households. And then for our different zones which we've developed, we know what the average distance would be. So to show you this, what we've got here is we've got a table of results based on the different zonation options and also the standard geographies which are readily available in terms of MSOA, LSOA, and OA. And we can see the mean distance to GP here and how that changes based on the zonation which we apply. And then we can also start to do other things with the data, so to take into account the deprivation level and to look at how that relates to the distance to the GP. And so our next step with this is to extend this further and to use some larger zonations where we're going to see much larger differences between the sort of options which are being presented here. So first of all, this project and what we're doing here is highlighting this pervasive nature of different geographical units and the influence that they're having over analyses. And we think that that's really important, and that choosing the right geography for your research makes a big difference. The next step here is really to take more of a control of the lower population threshold, so the minimum population targets which we're working with. For our initial zonations, we've been quite generous here, but our next step is to tighten up a bit on that. And this is a key disclosure constraint, so control for data providers. So it's going to be really important to do some sensitivity analyses around that and see what the changes are. And then more broadly, our research and the approach is seeking to understand how to maximize the protection for the data provider. So how can we be sure that the data provider is very comfortable releasing really detailed geographies, and at the same time to maximize the data utility for the researcher. So what's going to be the best thing for the researcher? So we can contribute to both of those points. In terms of the transparency of the approach, we think that that's a sort of further consideration, and that there's the potential to quantify the zone design solution and to release that information to the researcher, which will make their research more transparent and can help them in terms of the analyses which they're completing. And then we would also say that this approach has a wider applicability to many forms of administrative and linked data. And indeed, we have other projects looking at that at the moment. So then I just have some acknowledgements and a couple of references. Thank you.